This video, we're going to talk about a little bit of the beginnings of projective geometry, which also happened in the 17th century. So let's just think about geometry just a little bit. For many centuries, geometry held the central place in the study of mathematics. The ancient Greeks lifted the study of geometry up to be a pure form of mathematics with their axiomatic proof-based approach. Based on the works of Euclid, Greek geometry reached its pinnacle in the works of Apollonius, Eudoxus, Archimedes, and Pappus, including their work with conics. Any algebraic thinking by the ancient Greeks was really done via geometric means. Islamic mathematicians developed algebra, but they used geometry for proofs of their methods. So even though they're starting to think of algebra as a separate thing, they're making sure that it's grounded in this Greek way of thinking. By the early 17th century, algebra had become able to stand on its own apart from geometry. And so mathematicians were able to look at algebraic equations without necessarily having to have a geometric picture to go along with it. But in the early to mid 17th century, advances in analytic geometry or Fermat and Descartes brought geometry and algebra back together again, now from the other side, where we're starting with the algebra and getting the geometry, getting graphs and so forth from equations, for example. But meanwhile, further advances in a synthetic approach to geometry continued. So an analytic geometry is geometry that's where we use algebraic techniques to prove something about the geometry, whereas synthetic is basically not really taking the properties of real numbers as given, but rather just working with the property of the geometry itself. In particular, geometry was applied to Renaissance art to gain perspective and simulate three dimensions. And projective geometry was built on these principles of perspective. So in perspective drawings, parallel lines are depicted with non-parallel lines in the actual drawing, but they meet at a vanishing point that's supposed to represent a point at infinity. Well, this led the mathematician Desargues to consider what would happen if we considered parallel lines actually meeting at an idealized point at infinity. Desargues tried to give a unified study of conics by using these projective type of ideas. He thought of all the basic conics as being sort of different firm versions of the same thing. We know that a circle looked at from a certain perspective could look like an ellipse, for example. And he was able to work with these things to try to come up with a unified version of conics, making use of these projective techniques. He looked at transformations of points and geometric figures in a plane, and he tried to classify properties that were invariant under certain projections. Of course, projections were also used in map making, right? So that was different projections were used to take a sphere and try to turn it into a plane to make a flat map. Cylinders have sides that include parallel lines. Cylinders were treated by Desargues as like cones whose sides meet at infinity. Cones, the sides come together to a point, and they said cylinders are basically the same thing, but that point, if you extend it on out, is at infinity. And by treating them this way, he was able to treat them in sort of a try to sort of treat them at the same time. Now, his techniques were not widely recognized and actually didn't influence things a lot in the short term because at the same time, Fermat and Descartes were working on their analytic geometry, which turned out to be a little more useful for the mathematics that was coming up in the coming decades. But a few more centuries later, Desargues' ideas were picked up again. By this time, mathematicians were considering several different kinds of geometries, and projective geometry then was one of those. And so projective geometry is a modern area of geometric study. So just a few little biographical things about Desargues here. He was born in 1591 and died in 1661. He lived most of his life in Lyon, France. His mechanical devices he made include some pumps. He possibly helped Cardinal Richelieu during the siege of La Rochelle. He worked some as an architect, and of course, as we've said, his big thing was he worked in projective geometry. He was part of a mathematical circle that centered around Mersenne and included Descartes, Pascal, and both Blaise Pascal and his father Etienne Pascal. Um, this is from a detail from a painting that's a mural uh, that was painted in 1855, a bit later. But this is supposed to be Desargues here, and he is discussing with Mersenne in the royal palace in Paris there. So Desargues was way ahead of his time in some ways, talking about projected geometry, but he was able to pick up on some of the ideas from the perspective drawings, and that gave him some new ideas to work with geometry. And these were picked up much later in more of a modern approach to geometry.